Okay, I've had a Dunkachino. There's no snow in the forecast for tomorrow, so we'll finally have class. So life is looking good this morning. Let's take a look at finding the sine of negative 22 pi divided by 3. Two things that I notice when I look at this particular theta, this angle we're going to look to find the sine of, is that it is negative, which says that we're going to be going in the clockwise direction. The other thing that I notice is the denominator here is 3. So this means we are looking at pi divided by 3. So here we have 1, 2, 3. So our pi is equivalent to 3 pi over 3. And then a complete revolution, or 2 pi, is going to be equal to 6 pi over 3. So when we take a look at our angle, we can see our numerator 22 is bigger than the numerator of 6 for the complete revolution. So we have more than one complete revolution within our theta. In fact, we're going to see that we have a few of them. So let's take a look to see how many that we have. We could actually draw it out on the circle. I'm not going to do that in this problem because there's going to be quite a few rotations and I'm afraid it might look messy and confuse people. So let's take a look at the fractions. So we have 22 pi over 3. Notice, I'm not dealing with the negative here. The goal here is just to back out the full revolutions of 2 pi, which is our 6 pi over 3. This negative sign, I'm not going to show it here. It's going to confuse us in the subtraction, and at this point, we don't need it. So we have 22 pi over 3 minus 1 complete revolution of 6 pi over 3, and that gives us 16 pi over 3. We can take out another complete revolution of 6 pi over 3, and now we are at 10 pi over 3. We can take out yet another complete revolution of 6 pi over 3. And now we are at 4 pi over 3. So our 4 pi over 3 gives us our terminal side. It will show us an angle which is less than the 2 pi or 360 degrees. Now we can't forget this negative sign, the direction that we have to move in. So we start here, we go 1 pi, 2 pi, 3 pi, and we end up there. So here is our theta, and this is the terminal side of our theta. To continue to find, because our goal is to find the sine of this angle, we want to find a reference angle. And when we look at our picture here, remembering that the reference angle is the angle formed by the terminal side of the theta and then the x-axis, and in this case, this is the side of the x-axis we're going to use. So this angle here, I'll call it alpha, is our reference angle. And we can see from the picture, this would be pi over 3 here. So our reference angle is going to be pi over 3. Algebraically, we would be able to arrive at that same information by taking our angle of 4 pi over 3 and then subtracting out the pi, subtracting out the x-axis, which is going to be 3 pi over 3. 4 pi minus the 3 pi is pi over 3, which is our alpha, our reference angle. So now we take a look at sine of pi over 3. And because you're all such good trigonometry students, you have these memorized, and you know immediately that the sine of pi over 3 is equal to the square root of 3 over 2. So our ratio is radical 3 over 2. The last bit of information we need to take a look at here is what is the sign, the SIGN, positive or negative. When we look at our reference angle, when we look at where we're at, the y values here are positive. Since sine can be represented as either y over r, or sine is equal to y if we're considering the unit circle, y is the variable that we're focusing on, y is positive, so our sine is positive. Another way you could consider determining the sine is our all students take calculus, what's going on in each of these quadrants. In the second quadrant where we're at, S, sine is positive, so a check that our sine is indeed positive, and that would be our final answer.